All right. So next, Jeremy Magland is going to talk to us about what he has been up to. So he is in Flatiron Institute, mathematician by trade, and he's in Center for Computational Mathematics. So he has built beautiful tools actually for analysis and access to the data online. And also he's done some stuff with the LLMs. I don't know if he's going to talk about that part or not, but let's hear what Jeremy has to say.
All right, great. Well, I'm really happy to be here, and thank you, Nima, for the invitation to speak and share about the work that I've been doing. And I'm excited to share this and move forward with new collaborations. So today I'm going to talk about browser-based collaborative neuroscience. So this slide, I don't think I even need to spend very much time on this because I think most of us agree that open science and open data is the way to go. Here's a quote from the Universal Declaration of Human Rights from way back in 1948, where everyone has the right to share in scientific advancement and its benefits. So I believe that science should be open. Obviously, this fosters discovery, reproducibility, collaboration, reuse, transparency and trust, which is very important for the public to understand, education, and I'll throw in the word benevolence there. So how do web applications support open science and open data? So I believe that less friction, having less friction is a way to do that, and less friction in general leads to better science. So in that list of items, I think especially for discovery, make it as easy as possible for people to access the data, and then they can discover data sets that are relevant to what they're working on. Collaboration, we don't want to always, well, I've had many years of experience of, oh yeah, why don't you send me that file, or why don't you upload it to Dropbox, and then it's like a couple days later and like, yep, I managed to get the file. Now, what was the format and all that? And it's just difficult. So after many years of that, I really believe in minimizing the friction in order to help with that. Transparency and trust. I mean, if the data is out there for everybody to see, that's the best way for it to be verified. And education, again, we want to make it easy for people to demonstrate things, send a link by email. Here, why don't you check this out? Click on the link, etc. So maybe you have had this experience. So have you had to, so you're trying to park your car, and it turns out that you need to install an app in order to pay for parking. Boo. Not good. Or if somebody sends you a file and then you need to sign up for some service and you need to create a password. Now that's pretty painful, I think, in order to access a file. So fortunately, I noticed that Odin Symposium organizers opted for a QR code and a simple passcode to access the agenda. So that's really good. I think we all appreciate being able to click on something and to be able to see it. So moving that, moving on to scientific data. So in 2019, I believe, Dandy Archive project started, and from a Brain Initiative Award, and also supported by Amazon Open Data Program. I'm sure most of you are familiar with this. So it's a public resource for publishing, sharing, and processing neurophysiology data. So I would consider this a very low-friction website for data exploration. So it's open source, which is great. Open API, which makes a lot of what I have done possible. Open API meaning that the website itself uses an API to access data from the backend, but it doesn't. You can also access that from Python scripts or from other websites as well. Login is only necessary for uploading and contributing new data. Then there's software from the Dandy team as well as Catalyst Neuro and the community. And so generally this promotes open science and open data. So you can explore a data set on Dandy, see all the metadata, and then you can click to view the files. It's very easy. And then you can now click on an NWB file to open with an external tool, and the tool that I have worked on in collaboration with Ben Dichter and Catalyst Neuro is called Neurosift. So from the Dandy portal, you can search for data sets, explore the metadata, but then when it comes time to exploring the actual contents of these NWB files, you can open this in Neurosift and view all these different visualizations, which are more are added all the time. So you can visit neurosift.app. You're welcome to do that and just click around and view the data. So here are some visualization examples. I think in the interest of time, I'm not going to click on these, but invite you to click around. You can go to the GitHub repo, and then if you scroll down, there's an examples link, which will bring you to some example of visualizations. So the trick here with Neurosift, what really makes it work is that it can stream data from remote HDF5 files. So HDF5 was a file format that was not created with the foresight of being cloud friendly. But NWB files are in HDF5 and on Dandy they're in S3 bucket. So there's a trick, some technology, WebAssembly and web workers that allow the browser to directly access pieces of data from the HDF5 file without downloading the whole thing, which is very important because some of these files are 200 gigabytes or whatever. We want to just be able to go to the website and start to interact with the data. And for even lower latency, there's a technology developed with the NWB folks called Lindy, where the metadata for the HDF5 file is all pre-indexed and stored in the cloud so that when you go for these pre-indexed NWB files, it's even faster to load up. So there's other capabilities of Neurosift beyond just viewing NWB files. You can do like a semantic search that's LLM powered. You can also search for neurodata type, browse the Open Neuro repository. That's sort of a new feature that's developing. Explore BIDS data sets. There's a knee view integration for viewing like MRI images. And you can add annotations, and there's even job execution, which for advanced visualizations, which I'm not going to get into here. So once a user has discovered and browsed a Dandy set and looked through it, the question is, okay, so that was very easy, just a few clicks on the browser. What comes next? So usually somebody would want to do a little bit further investigation, like, okay, let me make a Python notebook to do this. So Neurosift can generate, there's a tab where it can generate Python usage script specific for that NWB file. And that helps the user get started with loading the data using PyNWB. So they can just copy this code into a script. But this does represent some points of friction. And you see that I have a very kind of high standard for how easy things should be. So the traditional flow is that you would download the NWB file, you would run a Jupyter Lab or Jupyter Notebook locally, edit IPython notebook scripts on your local computer, and once you have something you want to share, you push to GitHub or GitLab. So ways to reduce friction in that flow, well, instead of downloading the whole NWB file, you can stream the data, and there's tools to do that, such as Lindy, RemFile, FSSpec, and PyNWB. Dandy Hub is a Jupyter Hub instance that Dandy provides where you can go and then you can use their resources and you don't have to run something locally. And then there's a new tool which I'm going to share that I'm excited about called NBFiddle. And what this is it's a streamlined approach to interacting with Jupyter Notebooks. So on Neurosift, there's an ability to link notebooks to a Dandy set. So you go and you can click, here's an intro notebook to a particular Dandy set, and you click and you open it in this program called NBFiddle. And the nice thing about this is you don't have to have a Jupyter server running. Now you could also go to that notebook on GitHub and it renders, but on GitHub you don't see like the Plotly interactive graphs and everything. So NBFiddle, you see, it renders these kind of interactive graphs which is something that you wouldn't normally be able to do with like a Jupyter notebook without having a kernel running in the background. So, and also the cells in this NB-Fiddle notebook are editable. So you can just go ahead and start editing code. You don't have to log in or anything. Of course, if you edit the code, you probably want to execute the cells after all. But then there's a way to kind of configure to connect to a local Jupyter server or to a Jupyter server in the cloud. And then there's integrated chat, the things that we've all sort of, or most of us have been getting used to, be able to chat with it. The AI has access to your whole notebook, and you can ask it to write code for you, and there's also code completions. So edits are stored in the browser. So you make edits. It's not like you have to manage IPython notebook files on your computer. All the edits are just stored in your browser. If you make changes and then you want to revert back to the GitHub version, you just click the revert button. Okay, but if you make changes and you want to share those changes with somebody else, you can click to share to the cloud, enter an access token for GitHub, and you can save it as a GitHub gist very easily. And then just share the link with somebody. They can immediately see your notebook and interact, connect to their own Jupyter. So you can try it out. It's nbfiddle.app, and eager to hear your feedback on that. Okay, so reducing friction further using AI. So this was a project from the pre-cosine brain hack, and Ryan, Ben, and I, and others sort of worked on this project the goal was to, for each public dandy set, provide an AI-generated introductory notebook to help people get started just loading the data, creating plots, and setting up basic analysis. So there's like 300 public data sets. We don't want to create intro notebooks manually for each one. Can we use AI to auto-generate these? Okay, so before I go on, we're going to pause a moment and just say, how can we be responsible with using AI for these types of purposes? We want to make sure that it's accurate and reliable. I guess, does it eliminate jobs and training opportunities? What's the environmental cost, ethical concerns? I think we need to kind of discuss what the guidelines should be about use of AI. First attempt is single-shot AI notebook creation, and it doesn't work because it's like creating a notebook imagine trying to create a notebook where you don't actually get feedback when you run the cells, but you're just going to create it in one shot. Well, a human can't do that. AI can't do that either, and what you end up getting is all these kind of humorous plots, such as this. My favorite one is the upper left, where it's a histogram of the number of spikes per brain area, and there's only one brain area, which for some reason is called root, and it's a nice histogram there, right? Block, and you just often get these kind of empty plots and things like that because it doesn't know what's in the data. It only sees what the meta information is. So what we need is an agentic notebook creator that can write and execute scripts, view plots, revise and repeat, and then gather the information. And once it has enough information, it can go ahead and write the notebook. So there's a tool maybe some of you are familiar with. It's called Klein, a VS Code extension, which is similar to Cursor or other tools for AI code software development. And this is open source. So what I did was, okay, so there's some limitations of Klein. Well, you can only use it as a VS Code extension. It's designed for software development, not necessarily for data analysis. And it uses actually a very large number of input tokens for completion requests. So what I did was create this Python package, very simple, called mini-Klein. It's a standalone adaptation of Klein that is not dependent on VS Code. Use the prompts and everything from Klein. Remove the unnecessary features. It's geared toward data analysis, and it uses fewer tokens, and it's flexible. You can use it with all different LLMs. And this was created at the pre-cosine brain hack as well. So mini-Klein has access to 5 tools. It can read files, it can write files, it can replace in file, it can execute a command, and something that's in mini-Klein that's not in Klein is to read an image, to use AI vision to this is really important to be able to get information about a plot, like a PNG file that was created by matplotlib. Okay, so this, to me, it's amazing that this all works, right? That the AI can view the plot that it's just created and see all the axes and the bar plots and everything and be able to reliably interpret what is in the plot, which it can. So here are the instructions for miniklein. Okay, so miniklein is like a Python package. You just give it instructions and a working directory, and it can go ahead and start writing files at its own discretion, autonomously creating plots, etc. But you have to give it detailed instructions on what it's going to do. So we say, okay, your notebook should provide an intro. It should include code to load and explore data structures. Make sure so you kind of describe what you want this notebook to look like. And this is an evolving process here. Figure out what is the right thing to do. But then you also have to give it command line tools for querying the Dandy API. So you have to say how to retrieve metadata for a Dandy set, how to list the files in the Dandy set, how to get detailed Python usage for information about individual files. So these are the tasks that are required. And then you give it a detailed plan about what it's supposed to do in terms of selecting files, creating scripts, inspecting the plots that it creates, revising the scripts, etc. Giving it some warnings about common pitfalls, about trying to access, there are certain things that different models make mistakes with, like trying to index arrays in certain ways. So you give it specialized knowledge about how to work with these things. Sorry, this is a random slide. I'm sneaking an opinion. I think personally that we should refer to AI agents as it rather than he, she, they. So a discussion to have. So there's a repo that's in progress. It's called Dandy AI Notebooks, and we've generated like 50 notebooks so far with various models. The results are very promising. It's exciting to see that this actually works. And then here are some example results. So in the interest of time, I'm not going to click on these links, but this is just a glance of what a notebook looks like. So it gives a description of the Dandy set, tells what required packages are needed. It goes through, it starts generating these plots. They're pretty good from what I've seen. Now it does make mistakes, and so we are also using AI to critique and rate the AI agent notebooks. So here's an example of a cell. The grading AI agent said the value added for this cell is 3 out of 3, and then it gives a rationale for why this cell is valuable and why it's correct. Here's an example of a mistake that was made where the plot was unhelpful. So the value added was only 1. There's some rationale, and then the identified problem, bad output image, the cross-correlation plot is empty, etc. So there is the ability to kind of go in there and identify problems. So, don't take a picture of this one, but it's a rough preliminary comparison where it shows that clearly Claude 3.7 Sonnet is the winner compared to the other models. Again, everything is preliminary and rough here, but I will say that the consensus among all of us who are working with this is that Claude 3.7 Sonnet is the most sophisticated and advanced of the models for this type of thing. Okay, so future directions. We want to be able to use AI and other technologies to make discovery and progress easier for all scientists, I believe. And I don't know what the pitfalls or dangers are going forward, but I think we don't want a situation where the AI is generating bad science and incorrect science and having people just trust it blindly. So we need to establish guidelines and figure out how to prevent that from happening. And I'd like to thank all my collaborators and to make this possible. So thank you very much.
Stefan.
Dandy AI notebooks, you mean? Oh, miniklein. It's GitHub, Magland, miniklein.
Further questions? Yarek.
What are you doing today? What will be tomorrow's product? Because you already crafted those in the past week.
Well, yeah, Mini Klein is kind of working on some notebooks right now, so we'll see. No, I'm just kidding. It's not. But that would be nice if it was.
Jerome?
I'm just curious, now that you've built this amazing AI infrastructure, do you think that could be used to fix the meta-analysis?
Fix the metadata of Dandy?
A lot of Dandy sets have
Yeah.
missing key information, and it's a big problem.
Yeah. No, I think that there's a lot of potential there. Maybe there's ways to automatically go through all the Dandy sets, identify what's missing, and then notify the authors, and maybe even give them suggestions of how they can fix it. Yeah. Thank you.
Is there any plan for using it for quality metric? Like when people want to submit data? Let's say we do like some sort of like a sweeping scan of the parameters, metadata, as Jerome was mentioning, and saying, hey, like, maybe your data doesn't have enough information. Or,
Yeah,
like,
absolutely.
It's problematic.
Yep. That's definitely, and just making the import process easier, I think there's a lot of opportunity for that as well.
Okay. All right, let's thank Jeremy.